In 5.2, we're going to be learning how to divide polynomials. We've got 3 different techniques. This first one that we're going to see in example 1 is actually just a really, really quick idea. So there are technically 2 different kinds. There's long division and synthetic division. With this first one, you can divide a polynomial by a monomial. So take a look at the numerator. The numerator is a polynomial, meaning it's got multiple terms, and then the denominator is a monomial. So first, you could have a type where it's just polynomial divided by monomial, then we're going to move into dividing by a binomial, which is 2 terms. So in this first one, when we're dividing by just a monomial, and this only works in this case, what you can do is you can take each piece of the numerator and divide it individually. So let me show you how you could write that. So taking each piece, let's take the first part of the numerator like that, divide it by the denominator. Do the same thing with the next one, minus 15ab cubed, divide that piece by the denominator, and then our third piece. So you're just taking each individual piece and splitting it up and dividing it by the denominator. Because really when you have this whole quantity divided by 5ab, it's like taking each individual piece and dividing it by 5ab. And then you're going to reduce down as much as you can, simplify it up. So here, 5 over 5 cancels, b over b cancels, and then a squared over a reduces down to just an a. Okay, here 15 over 5 reduces down to 3. A's cancel. B cubed over b reduces down to b squared. And then 10 over 5 reduces down to 2. A cubed over a is a squared. And b to the 4th over b is b to the 3rd. So just reducing them individually. If you notice, all the denominators have completely canceled out, and then I'm just going to rewrite for our final answer. So this one, just an a was left over, minus, there's a 3b squared, plus 2a squared b cubed. So this is what you'd have left over when each of these pieces, in turn, gets divided by that 5ab. So your final answer would be a new polynomial that looks like this. If you're dividing polynomial by polynomial, we're going to use numerical long division. I know some of you may not have learned it this way, so I'm going to recap how to do numerical long division. So 6,043 divided by 18. What you do is you take this and you just try to divide it in from left to right. So 18 won't go into 6, so we move to 60. So 18 going into 60, you just see how many times it will go in completely, and then you're going to end up having a remainder. So 18, and then 36, 54. Okay, so that's 3 times. So I know it'll go in at least 3 times. Then you multiply 3 times 18, and that's 54, and then you subtract 54. Okay, so subtract 54, we get 6, and then bring down the next number. So bring down the 4. Then 18 into 64 would still only go in 3 times. It's not enough to have a 4th copy of 18. Then I take 3, multiply it by 18. Again, that gives me 54, and I subtract it. I have 10 as a remainder, and then I bring down the 3. Okay, and then 18 going into 103. I know 3 times is 54, 4 times is 72, 5th time would be 90, so that's all we've got room for. So a 5th time minus 90, and that leaves me with 13. So the way that I officially write it is I take what I had up here, 335, and then you take your remainder divided by your divisor here. Okay, so that would be how you write the final answer. So it's going to be really similar for polynomials. Okay, so polynomials, we go like this. Take that first part, divided by x minus 5. Okay, so the process is going to be super similar. You're going to see how many times it goes in, multiply these 2 together and subtract, bring down the next term, see how many times this goes in here, multiply and subtract, bring down the next term, see how many times this goes in here, multiply and subtract, write the remainder over the divisor. So the process is the same. It's obviously a little bit more complicated when you're working with polynomials. Okay, so the only thing that's slightly different is since we have multiple terms, we're literally only going to focus on this term. Okay, so we want to know, just like we wanted to know how many times does 18 go into 60, we want to know how many times does x go into x squared. And I'm going to phrase that in a slightly different way. Instead of thinking how many times does x go into x squared, I want you to think, what do I multiply x by in order to get x squared. Here, it's like, what did I multiply 18 by in order to get as close as I can to 60? And you multiply 18 by 3 to get as close as you can to 60. Here, if I multiply x by x, then I get x squared. So it's an x that I'm going to put right here. So again, that's because I multiply x times x in order to get x squared. So then I do just what I did up here. I multiply 3 times 18 and subtract what I get. I'm going to multiply x times x minus 5 and subtract what I get. Now, since I'm subtracting a polynomial, super, super, super important that you use parentheses. Super important. So multiply x. X times x is x squared. X times negative 5 is negative 5x. Now again, these parentheses are vital because when I'm subtracting, you want to make sure you're subtracting both these terms. These will cancel. Then I have a negative 2x minus negative, so plus 5x. Negative 2x plus 5x is 3x. So that's like subtracting here and getting the 6. Then you bring down the next term. So now I'm going to bring down the minus 15. Okay, and then how many times does x go into 3x? AKA, what do I multiply x by in order to get 3x? And that would be 3, a positive 3. And then I do the same thing. I take 3, multiply it by this polynomial, subtract, and it is super important to have parentheses. 3 times x gives me 3x. 3 times negative 5 gives me negative 15. In this case, everything canceled out, and I actually did not have a remainder. If I did have a remainder, I would put that over x minus 5, just like I put this over 18. Okay, so my answer that I get is x plus 3. Okay, we're going to do one more example. And this is actually a standardized test example, so you've got multiple choice options here. So this, remember when you've got this negative first power, it means it's like taking this and dividing by 2 minus a. Okay, so we can rewrite it like that. So I'm going to set up my long division just like I did in the previous problem. Okay, it's also really important that these terms go in order of power. So I'm actually going to put the negative a first, then the positive 2. So it's a good idea to rearrange this and put it in this order instead. Okay, so now just like the one on the previous page, I'm really only focused on that leading term. That's why I had to switch the order, because this is my leading term because its power is bigger. So negative a divided into a squared. In other words, what do I multiply negative a by in order to get a squared? And that would be another copy of negative a, because negative a times negative a gives me positive a squared. So I'm going to multiply and subtract. When I subtract, I need my parentheses. So multiply here. Negative a times negative a is a squared. Negative a times 2 is negative 2a. Be careful when you're subtracting. This is really negative 5a plus 2a. Okay, so now again here, what do I multiply negative a by in order to get negative 3a? And that would be 3. Okay, multiply and subtract. Don't forget your parentheses. 3, distribute it here. I'll have negative 3a plus 6. Subtract carefully. This is really 3 minus 6, which leaves me with a negative 3. So that's my remainder. So I start with the negative a plus 3, and then I write my remainder over my divisor. Okay, so that's my answer. Let's see if we can match it. That's not it. That looks super close, but let's see. Nope, it's actually that one. See the difference here? I have a plus here, a minus here, and this is actually a negative 3. So it would be option D. Okay, the second division method we're going to be learning is synthetic division. It's almost like a shortcut. It only works in certain cases though. So I'm going to give you guys the step-by-step, and as I'm giving you the step-by-step, I'm going to go through this example, because just looking at the words, your mind will be spinning trying to figure out what the words mean. So I'm going to write down each step and then do each step in example 4 part A. So first part, step 1 right here, is we write the coefficients of the dividend in descending order. And there is more than that to this first step, so make sure you do have a little space. So this is what this means. So our coefficients, we've got 1, Then the coefficient on the x squared is negative 4. Coefficient on the x is 6. And then the constant is negative 4. So that's what that means. So you write them in descending order. If one of them is missing, you leave a 0. You've got to make sure every single one of these is accounted for. So again, if something is missing, like right here, see we've got an x squared missing there, you'd leave a 0. Okay, so that's a super important part. Next, write r of x minus r in a box. Okay, that's going to seem a little strange, just writing the words, but it goes like this. So x minus 2, so this is literally x minus r, so you write this 2, and then put it in a little box, like that. Okay, so that is the divisor. The reason we put a 2 here and not a negative 2, picture if you were to solve this, if you were to take like x minus 2 and set it equal to 0, what you get is 2. So what's going in the box is actually the opposite of what you see here. Okay, and then the last step of the last part of the first step is to bring the first coefficient down. Okay, so bring the first number down. I'm trying to abbreviate as much as possible. So this one just gets a free pass down like that. Okay, so this is like the setup. It's going to look a little bit crazy. Once we get going, I think you'll get the hang of it. Okay, so step 2, multiply the first coefficient by r. Okay, multiply the first coefficient by r and write the product under the second coefficient. Okay, so we multiply 1 times 2, and then we write the product under the second coefficient. Okay, so 1 times 2, we get 2, and we write that right here under the first coefficient. Okay, add the product and the second coefficient. So that's step 3. Oops, misspelling things here. Coefficient. Okay. So now this is going to be like a big addition problem here. So now I just combine these up. Negative 4 and positive 2, I get negative 2. And then step 3 is you just repeat this process until you go all the way through. Okay? And there's going to be more to write on this step, so save room. So repeat the process. So negative 2 times 2, we get negative 4, so we write that here. Then we add these two numbers together, and we get 2. 2 times 2 is 4. We add these numbers together, and we get 0. So the process repeats. Process repeats until we're done, until we reach this last column. Okay, so now here's how we figure out what our answer is. So the numbers along the bottom row are the coefficients. Okay, we drop down a degree. Okay, so the numbers in the bottom row of a polynomial with one less degree. Okay, so this degree was 3, so one less degree would be 2. So 1 x squared, negative 2x, positive 2, and then if there was anything here, it would be the remainder. Okay, the final number is the remainder. Okay, this means there's no remainder, which means it divides evenly. So that would be your final answer. Okay, seems a little weird. A lot of words here. Once we get going, it's actually going to be a very, very quick process, and you're going to be happy that you know it. Okay, so step 1, write the coefficients in descending order. So this one, 6b to the 4th, negative 8 b to the third. There is no b squared, right, is 0. That part is super, super important. If you forget to do that, you're going to mess the whole thing up. And then 12b, and the constant is a negative 14. Okay? Put the opposite of this number in a box. So b minus 2 means you put positive 2 in a box. And then we just bring this first number down. Okay, and then we start our algorithm. So 6 times 2, we get 12. Add these two numbers together, we get 4. 4 times 2, we get 8. Add these two numbers together, we get 8. 8 times 2 is 16. Add these two numbers, we get 28. And 28 times 2 is 56. Add these two numbers together and we get 42. Okay, so I basically just ran us all the way through step 4 here, all the way up to repeat this process. The numbers are now a polynomial with one less degree. So this degree is 4. So we start tacking them on to a polynomial of degree 3. So 6b cubed plus 4b squared plus 8b plus 28. And then remember, this is the remainder. So we put 42 over the divisor, which is a b minus 2. Okay, and that's your final answer. So like I said, once you get going, it's actually really, really quick. So we've got one little thing to add on here, and that's if you have something like this. If you have something like that where you've got a 2 in front of the y and not just a y, because the ones we had before were just an x, just a b. So if you do have something, what you actually have to do is divide everything through by that number. Okay, so rewrite the division expression. So divide everything through by that number. Okay, divide everything through by that number. All right, so take everything we've got, divide everything here by 2, divide everything here by 2. And again, I'm just picking 2 because that's the number in front of the y. Okay, so now I'm going to rewrite it. Divide everything by 2. So 4y cubed becomes 2y cubed. 6y squared becomes 3y squared. 4y becomes 2y, and then minus 1/2 divided by y minus 1/2. Okay, so now that it's in this form, we can set it up exactly the way we did before. So we take our coefficients in descending order. So 2, negative 3, 2, and negative 1/2. Put the opposite of this number in a box, so 1/2. Okay, now here's the algorithm. This number just goes down, and then we start our multiplying and subtracting. So multiply 2 times 1/2, we get 1. Add these two numbers together, I get negative 2. Multiply these two numbers together, I get negative 1. Add these together, I get 1. Multiply these two together, I get 1/2. And lucky for us, we add these together and we get 0. So that means there's no remainder. So now these are the coefficients of a polynomial with one less degree. So one less degree would be y squared. So I write 2y squared minus 2y plus 1, and there is no remainder. So that is your final answer.